Hello everybody, so today I will talk about physics. The topic today is about electric field and electric force. So now I will show you the technique. We have the diagram in here and we have three units. We have two positive charges and one negative charge. So the first question they want to ask, what is the value of the electric force at the origin? So we need to find the force at the origin in here. So we need to find the distance between the negative charge to the positive charge. If we look carefully, we can draw this one going here, and this is just like the right triangle. If we want to find the distance between this one and this one, you need to use about cosine 45. So we got about cosine 45 equals to 6 centimeter divided to d. So I put about d number 1 and d number 2. That's about the distance between the Q number 1 to Q number 2, and this is about Q number 3. So we got about D12. That should be about number 6 divided to cosine 45. And we got about 6 multiplied with the square root of number 2 centimeters. Now let's go to find the force F12. So that should be about K multiplied with the absolute value of Q number 1 and Q number 2, and we divide to the R just like the distance, and that should be about R12 square. So we have K is about Coulomb constant. That's about 9 multiplied with 10 to the power of 9. And we have Q number 1. That's about 4 NC. So that should be about 4 multiplied with 10 to the power of negative number 9 multiplied with negative number 2, 10 to the power of negative number 9 over 6 multiplied with the square root of number 2 multiplied with 10 to the power of negative number 2, because we need to convert centimeters into meters, and we put the power 2 in here, and this is approximate about 1 multiplied with 10 to the power of negative number 5 Newton. So the next one, that's about F1 and number 3. So we got about the formula in here. So K should be about 9 multiplied with 10 to the power of 9, and we have the absolute value of, we have number 4 and we have number 3. and the distance is about 4, so we need to put about 4 multiplied with 10 to the power of negative number 2, everything to the power of 2. So we got the answer in here. You got about 6.75 multiplied with 10 to the power of negative number 5 Newton. Now, after we got F12 and F13, we need to find the force applied to origin in here. So we look carefully about this one. This is about positive and positive, so this is repelled. This one go in here. We have negative and positive, so this is attract, go in this way. And we know that this is about F1, 2 and F1, 3. So we want to find the force of F number 1 go on this way in here. So the formula to get F number 1, that should be about F1 equals to the square root of F12 square plus F13 square plus 2 F12 F13 cosine alpha. So the alpha in this situation is about 45 because this is about a right triangle. You got about 45 in here, so the angle in here should be about 45. Now we just input all the number in here and we got the final answer. The answer is about 7.49 10 to the power of negative number 5 Newton. So this is the final answer for the question A. Now let's go to the question B. The question asks, what is the value of the electric field? So the formula that is about E equals to F divided by Q. So we just find origin, that's about this one. So the answer in this situation, we have E number 1 equals to F number 1 divided to Q number 1. F1 we just calculate in here, that's about 7.49 10 to the power of negative number 5. And Q number 1, that is about the given number in here, and this is about 4n, and we put about 4 multiplied with 10 to the power of negative number 9, and we got the final answer in here. That should be about 18,726.39 Newton per Coulomb. That's the end. Thank you for watching.